China is rewriting the rules of construction, embarking on mega projects so ambitious they leave engineers around the globe awestruck. We're not just talking bigger, we're talking bolder. Massive dams generating record-shattering amounts of electricity, tunnels carved through some of the planet's most challenging terrain, and bridges that seem to defy gravity, appearing to float in midair. What's even more remarkable than the sheer scale of these projects is the speed at which they're completed. China has earned a reputation for constructing vast highways, sprawling bridges, and sleek high-speed rail lines at a pace that seems almost unbelievable. This relentless pursuit of progress is fueled by a potent combination of advanced technology, innovative construction methods, and an unwavering national determination. This rapid transformation of blueprints into tangible reality has left many asking, how does China do it? What are the secrets behind these engineering marvels that seem to rise from the ground up in record time? Let's delve into the world of Chinese megaprojects and uncover the ingenuity, determination, and sheer scale of these modern wonders. Zhuhai-Macau Bridge. Imagine a bridge so long it stretches beyond the horizon, a 55-kilometer ribbon of concrete and steel connecting Hong Kong, Zhuhai, and Macau across the churning waters of the Pearl River estuary. That's the reality of the Hong Kong-Zhuhai-Macau Bridge, the world's longest sea crossing, and a testament to China's ambition to transform the Greater Bay Area into a global economic force. Building this megastructure wasn't just about connecting points on a map. It was about overcoming a gauntlet of engineering challenges. Imagine navigating frenetic shipping lanes, battling the fury of typhoons, all while safeguarding the delicate marine ecosystem, including the habitat of the iconic Chinese white dolphin. The solution: a complex symphony of bridges, artificial islands, and a tunnel that plunges beneath the waves. The main bridge itself stretches a staggering 29.6 kilometers, supported by slender single-column piers anchored deep into the seabed. This design minimizes disruption to shipping lanes and the sensitive marine environment. 3 cable-stayed bridges, each crowned with distinctive sail-like towers, add a touch of artistic flair to this engineering marvel. And then there are the artificial islands, meticulously engineered structures that act as giant traffic interchanges in the middle of the ocean. These islands provide a seamless transition from the colossal bridges to the 6-kilometer-long submerged tunnel. Speaking of the tunnel, imagine constructing a roadway not by boring through the earth, but by carefully lowering 33 gigantic concrete sections, each weighing an astounding 880,000 tons, into the seabed. That's exactly how this underwater highway was built, a testament to the precision and power of Chinese marine engineering. Over a 9-year period, massive construction teams, specialized machinery, and a constant flow of materials had to be coordinated across both land and sea. The result? A journey that once took hours by ferry now takes a mere 40 minutes by car, drastically cutting down travel times and facilitating the movement of people and goods. The bridge stands as a potent symbol of connectivity, boosting trade, tourism, and solidifying the region's future as an economic powerhouse. Baihetan Hydropower Station. Picture a hydropower station so massive it redefines the scale of clean energy production. That's the Baihetan Hydropower Station in China. With a capacity of 16,000 megawatts, this behemoth can generate over 62 billion kilowatt-hours of electricity annually, enough to power millions of homes. But beyond the numbers lies a story of remarkable engineering achievements. At the heart of this power plant are 16 colossal turbines, each capable of generating an astonishing 1,000 megawatts of power, the largest ever built. This decision to use fewer, larger turbines translates to significant cost savings, simplified maintenance, and an unheard-of energy conversion efficiency of 96.97%. Designing and building these gigantic turbines was no easy feat. Each one features a complex water guide mechanism, a critical component ensuring the smooth and efficient flow of water into the turbine. SKF's advanced sealing technology plays a critical role here, minimizing water leakage around moving parts and boosting overall efficiency. Holding back the immense force generated by these turbines is a 289-meter-tall concrete arch dam. That's as tall as a 100-story skyscraper. This structure is a marvel in itself. meticulously engineered to withstand a mind-boggling 16.5 million tons of hydraulic pressure and stand strong against extreme floods and earthquakes. And to manage water flow during emergencies, a massive quick-energy gate, powered by the world's largest hydraulic hoist, stands ready. This colossal cylinder, equipped with a ceramic-coated piston, can lift the equivalent of 800 cars with ease. Ensuring the smooth operation and incredible load-bearing capacity of this hoist, even in the challenging humid environment, are SKF's specialized spherical bearings. But it's not just about raw power, it's also about precision engineering. SKF's sealing technology ensures the flawless operation of this critical hoist, preventing hydraulic fluid leaks and protecting its internal components. Specialized materials, designed to resist friction and creep, contribute to the long-term reliability of the hoist under immense and constant pressure. The Baihetan Hydropower Station is more than just a source of clean energy. It's a testament to the power of human ingenuity and a symbol of China's commitment to a sustainable future. Huoshenshan Hospital. Imagine a pandemic sweeping the globe, pushing healthcare systems to their limits. That was the stark reality in Wuhan, China, in early 2020. The solution? Build a 1,000-bed hospital in just 10 days. The Huoshenshan Hospital was strategically erected on an existing logistics site, saving valuable time on land preparation. But the real key was prefabrication, where building components are manufactured off-site, like giant Lego blocks for a hospital. Walls, plumbing systems, even patient rooms arrived on site pre-assembled, ready to be slotted into place. This eliminated time-consuming on-site construction like bricklaying and welding. Think of it like assembling a life-size model kit, but on a massive scale. Over 7,000 skilled laborers worked around the clock, their movements a symphony of coordinated effort. Electricians installed pre-wired panels as plumbers connected pre-built units. The result? A 34,000 square meter hospital, complete with isolation wards and advanced medical equipment, ready to receive patients in a mere 10 days. This feat was possible thanks to foresight and meticulous planning. Months prior, Chinese authorities had invested in prefabrication facilities, churning out standardized building components in anticipation of future emergencies. When the crisis hit, they were ready. Advanced 3D modeling software allowed engineers to digitally design and assemble the entire hospital beforehand, ensuring every piece fit together perfectly, minimizing on-site adjustments and delays. It was like a giant jigsaw puzzle, digitally assembled before being brought to life. Logistics played a crucial role. A steady stream of prefabricated components flowed to the site through dedicated trucking routes and prioritized checkpoints. While the factory hummed, the site was prepped. Ground leveled, foundations poured, utility trenches dug. It was about maximizing efficiency, every step planned to avoid bottlenecks and delays. This wasn't just about speed, it was about quality and functionality. Isolation wards were equipped with negative pressure ventilation systems to prevent the virus's spread. Advanced medical equipment arrived alongside the prefabricated units, ensuring the hospital was operational the moment construction ended. The Huoshenshan Hospital stands as a beacon of hope and a testament to human ingenuity, demonstrating that even in the face of overwhelming challenges, with innovative approaches and unwavering resolve, seemingly impossible goals can be achieved. Marlowe Dam. China stepped into the African spotlight in 2003 when it began construction on the Marlowe Dam, a behemoth aiming to be the largest contemporary hydropower project in Africa. This colossus stretches across the Nile River in Sudan, roughly 350 kilometers north of the bustling capital, Khartoum. But the Marlowe Dam isn't just about size, it's a marvel of modern engineering, harnessing the Nile's mighty flow to generate electricity for millions. At a staggering 9 kilometers long, the dam's sheer scale is enough to steal your breath away. Imagine a wall over 5.6 miles long, its crest reaching up to 67 meters. That's taller than a 20-story building. But the dam isn't a single, uniform structure. Chinese engineers designed it with a multi-pronged approach to maximize efficiency and stability. The core of the dam lies in the left river channel, where an 883-meter-long earth-core rock-filled dam stands guard. Picture a giant mound of earth and rock, its core meticulously compacted to form an impermeable barrier. This isn't the only line of defense, though. Flanking the earthcore dam on either side are massive concrete-faced rock-filled dams. The right bank boasts the larger of the two, stretching 4.3 kilometers and reaching a height of 53 meters. The left bank's dam isn't far behind, clocking in at 1,590 meters long and 50 meters high. But dams aren't just about holding back water, they need to control its flow for power generation. This crucial role falls on the dam's live water section, situated on the right bank of the Nile. Here, a network of sluices allows for controlled water release, while a 154-meter-long spillway ensures safety by providing an overflow channel during periods of high water levels. However, this section's crown jewel is the 300-meter power intake dam, which houses the turbines that convert the Nile's energy into electricity. Speaking of turbines, the Marlowe Dam boasts 10 125-megawatt Francis turbines. Each of these mechanical marvels is designed to handle a flow rate of 300 cubic meters of water per second, a mind-boggling amount. Imagine 10 giant water wheels, each spinning with the force of a raging river, turning out a combined potential electricity yield of 5.5 terawatt-hours annually. To handle this surge of power and distribute it across Sudan's vast network, a massive upgrade of the country's electrical grid was undertaken alongside the dam construction. This ambitious project involved laying over 1,500 kilometers of new transmission lines, including a 500 kilovolt aerial line that cuts across the Beta Desert to reach Atbara, Omdurman, and Khartoum further east. 220 kilovolt lines snake their way towards Port Sudan, while others head west along the Nile, connecting Merowe to Damazin and Dongola. But beyond its grand scale, the Marlowe Dam is a complex feat of design and construction, where every meter of the dam wall, every cubic meter of water flow, and every megawatt of electricity is meticulously calculated to achieve optimal efficiency and performance. Humming Tunnel. China's reputation as an infrastructure powerhouse comes from its boldness, a willingness to tackle projects that others deem impossible. One such challenge was the Humming Tunnel in Gansu Province, labeled the most difficult tunnel to build. A mere 173 meters of this tunnel left engineers worldwide stumped, even after Germany, a nation renowned for its engineering prowess, threw in the towel. Yet, China persevered, and after 6 long years, the seemingly impossible tunnel was finally completed. So what made the Humming Tunnel so uniquely problematic? It all boils down to geology and location. This tunnel wasn't just cutting through solid rock, its path crossed a reservoir and a river, saturating the surrounding earth. The soil was predominantly loess, a notoriously loose and unstable material that tends to liquefy when disturbed. Think of trying to tunnel through quicksand. Imagine the scene. Digging commences, and the soil around the tunnel starts to crumble and shift. Cracks appear, threatening to collapse the entire structure. To make matters worse, heavy rains would further destabilize the ground, potentially leading to catastrophic cave-ins. Safety concerns loomed with every meter of progress, with conventional methods proving ineffective. China sought the help of international experts, but expert after expert, faced with the Humming Tunnel's loose waterlogged earth, was left scratching their heads. No feasible solution was in sight. The tunnel quickly became a symbol of engineering's limits, appearing on lists of the world's most intractable construction problems. It earned the nickname Tofu Tunnel, highlighting its frustratingly fragile nature. But China wasn't about to give up. Determined engineers devised a daring plan, combining innovative technologies and meticulous execution. They adopted a cautious, step-by-step excavation method alongside vacuum dewatering to stabilize the soil. The work was fraught with danger. Sudden surges of water and sand into the tunnel became a terrifyingly common occurrence. Over 6 years, a team of 1,200 workers toiled in shifts to overcome the challenges. Progress was painfully slow, averaging a mere 2 to 3 meters per day. The harsh climate added further hurdles. In icy winters, an entire team was dedicated to ice breaking to prevent the waterlogged soil from freezing over, which could halt construction entirely. But perseverance paid off. Finally, after 6 grueling years, the Humming Tunnel was complete. News of its success echoed around the world. It became a testament to Chinese engineering ingenuity, a symbol of the nation's refusal to yield in the face of immense challenges. The Humming Tunnel, while small in size, represents a massive victory for China. It filled a critical gap in the Lanwu Railway, a lifeline connecting the Yellow and Yangtze River basins. Its economic impact ripples across the region, boosting trade and tourism along its route. Three Gorges Dam. Picture the mighty Yangtze River, once a force of nature, carving its way through the breathtaking Kango and Shiba Liang gorges. Now, imagine this untamed river harnessed, its power transformed into electricity and a navigable highway through the heart of China. This vision became a reality with the construction of the Three Gorges Dam, an engineering marvel that stands as the world's largest hydroelectric project. This dam is nothing short of colossal. It spans a mind-boggling 2,335 meters across the river and towers 185 meters high. To create this behemoth, engineers used a staggering 28 million cubic meters of concrete, enough to fill thousands of Olympic pools, and integrated 463,000 metric tons of steel into its monolithic structure. But the Three Gorges Dam isn't just about size, it's about reshaping a landscape to unlock the river's potential. The dam's construction flooded the three scenic gorges, creating a vast reservoir that stretches 600 kilometers upstream. This new deep-water highway allows massive, ocean-going freighters to sail over 2,000 kilometers, inland from the East China Sea all the way to the bustling city of Chongqing. Think of the logistics required to navigate this massive dam. Engineers designed a series of 5-tier ship locks, capable of lifting and lowering vessels weighing up to 10,000 tons. For smaller ships seeking faster transit, there's an even more incredible feat of engineering: the world's largest ship lift. This colossal elevator for boats bypasses the locks, ensuring swift passage past the dam. The heart of the Three Gorges Dam lies in its power generation. Deep within its massive structure, 32 powerful turbine generators spin with the force of the Yangtze, turning the river's flow into electricity. These turbines make the Three Gorges Dam the most productive hydroelectric power station on Earth. In 2020, it generated a record-breaking 111.88 terawatt-hours of electricity, enough to power millions of homes and fuel China's relentless growth. The Three Gorges Dam was also built to provide a vital defense against the devastating floods that historically plagued the Yangtze Basin. Construction on a project of this scale was an epic undertaking. It involved displacing communities, excavating over 100 million cubic meters of earth and rock, and pouring millions upon millions of cubic meters of concrete. This colossal construction site buzzed with thousands of workers, a testament to the sheer human effort and engineering feats required to tame a river and transform a landscape. Glass Bridge. China isn't just about massive dams and colossal power plants. Sometimes its mega projects are built on a foundation of audacity and glass. Have you ever dreamed of walking on air? Picture yourself suspended 300 meters above a breathtaking canyon, a mere sheet of glass separating you from the vast expanse below. That's the spine-tingling experience of crossing China's Zhangjiajie Glass Bridge, the world's longest and highest glass-bottomed pedestrian bridge. This marvel of engineering pushes the boundaries of both construction and perception, creating an illusion of weightlessness that will leave you in awe. Stretching 375 meters across the Zhangjiajie National Park, this transparent walkway is supported by massive steel girders filled with reinforced concrete. The bridge weighs a colossal 2,200 tons, a reassuring heft for those who dare to tread on its glassy surface. With a budget of around 460 million yuan, roughly $68 million, no expense was spared in ensuring both its beauty and its safety. The true magic of the bridge lies in its glass deck. It's constructed from a triple layer of specially hardened glass, each layer a substantial 50 millimeters thick. This isn't the kind of glass that shatters at the slightest tap. To prove its resilience, engineers conducted the ultimate stress test. They drove a 40-ton truck over a glass panel, resulting in a mere 2-centimeter deflection. They even invited people to smash the glass with hammers. While the top layer shattered as expected, the crucial bottom layers remained intact, an undeniable testament to the bridge's strength. However, building a see-through bridge at such heights presented unique challenges. Wind forces at that altitude are a major concern. The original design featured glass handrails, but that idea was quickly abandoned. Those railings would have acted like sails in strong winds, potentially destabilizing the entire structure. To combat this, discrete steel poles were used instead, allowing winds to pass harmlessly through and minimizing vibrations. Safety features go beyond the sturdy construction. Giant glass balls, each weighing a hefty 500 kilograms, hang beneath the bridge to dampen vibrations. Massive water reservoirs further stabilize the structure. Finally, strategically placed bends in the railings break up the rhythm of walking pedestrians, preventing the kind of resonant vibrations that famously plagued London's Millennium Bridge when it first opened. These features ensure that the Zhangjiajie Glass Bridge can handle both the crowds of thrill-seekers and the whims of nature. The result is a bridge that offers more than just a terrifying walk. Bungee jumpers can now plunge towards the canyon below, adding an extra layer of adrenaline to the experience. But what makes this bridge truly unique is its ability to make you feel like you're floating in mid-air as you step out onto the transparent glass. The world seemingly drops away beneath your feet. The focus isn't on the bridge itself, but on the breathtaking expanse of the canyon, giving you a bird's-eye view that's both exhilarating and slightly mind-bending. It's a testament to the power of engineering and design working together to create an experience that transcends mere construction and transforms into an unforgettable adventure. Thank you for watching. Share your thoughts in the comments and don't forget to subscribe to Global Mega Projects.